All right, today's lesson is 18 lines and angles. What's our objective, class? Get ready?
18 lines and angles.
Lines and angles. Yes, today you're going to be able to draw, identify, name, and notate different kinds of lines and angles. You'll be able to measure angles too. So you'll need a protractor if you don't have any. Hang tight, we'll get to some later. All right, so let's start with line. We're going to talk about how to identify it and how to name it. So a line looks like this, straight with arrows on both sides. And when we name it by 2 points on the line. So I say line A, B. How do I say that, class? Get ready?
Line A, B.
Line A, B. Let me show you some ways that students have done it that I marked wrong. Line ACB is wrong. Only give me 2 points. Segment AB, wrong. It's not a segment, it's a line. Plane AB, nope, that's wrong as well. It's got to have 2 points listed, and it has to have arrows above it. That tells me that it's a line, not a segment or a ray or a point, okay? All right, so a ray has an endpoint, goes in one direction. I think of it like a flashlight. It has a starting point or an endpoint and goes in one direction to infinity. And we're going to call the endpoint E and some point on the ray F. We name this ray E, F. How do we name this? Get ready?
E, F.
Ray E, F. This one you don't have to draw the point. I just did out of habit, but you notate it with a little miniature ray above the 2 letters. The wrong way to do it would be to say ray F-E. You see why? Okay, AJ?
It's because FE would be like saying that's going the other way and not the way that it's actually going.
The direction matters, so I notate it by starting with my end point. I start with the end point, all right? Let's see, a wrong way to do it would be to say ray EF. That's not a ray, right? There's no arrow. And if I just said EF, that's also wrong. That doesn't say that it's a ray. It doesn't tell me what it is. So this is the only right way to do it. See, these are all things I've seen students do. Okay, next segment. Segment has 2 end points. We'll call this GH. And we notate it, segment GH. You don't have to draw dots at the end, just a bar is totally fine. Segment GH. What is it called? Get ready?
Segment GH.
Good. Segment GH. Does it matter if I say HG?
Yes.
It's actually, direction doesn't matter because it doesn't have. All right, where we left off. So let's talk about planes. Planes are a 2-dimensional flat object. And we can name a plane by its 4 vertices. So A, B, C, D. We would say either the word plane, A, B, C, D, or we could do a miniature drawing of a plane, say plane A, B, C, D. The wrong way to do it would be to say plane C, A, B, D. See how my vertices are like skipping around? That would be the wrong way to do it. So you have to make sure you start at 1 and you have to go in order. But it doesn't matter where you start, you just have to go in a consecutive order. Perpendicular are when 2 lines intersect at a right angle. What type of angle? Get ready?
Right.
A right angle. So perpendicular lines look like this. Here's the thing that my 6th graders sometimes struggle with. Are these perpendicular?
No.
Yes, they are.
They are. My 6th graders have a hard time. They think that everything has to be vertical and horizontal because that's all they've done so far. But if I turn it, it still meets at a right angle, right? Okay, so we're going to name it A, B, C, D. And we're going to say line AB is perpendicular to line CD. So this is the symbol we use for perpendicular. It's an upside down capital T. This symbol means perpendicular. What does this symbol mean? Get ready?
Perpendicular.
Perpendicular, good. Okay, the next one is called skew. Now skew has to do with 3-dimensional space. So you have to think about, the application of this would be, picture airplanes flying in the air. They don't want airplanes all flying in the same plane of space because they're more likely to have a collision. So they'll have, some airplanes will fly up here at this altitude, some airplanes will fly at this altitude, and they're in a different zone. So picture a box I might have an airplane flying on this line or this plane of space, and I might have another airplane flying on this plane of space. So can they collide? They couldn't. Okay, let's add some direction to it. Suppose I have an airplane flying this way, and I have an airplane flying this way. Can those airplanes collide? Okay, let's see. This one's going straight here. Okay. This one is going right here.
No.
Okay, it's hard to see three dimensions. Can you see that? Here's my airplane. Can they collide?
I got to build around.
The only way they could collide is if this plane, if this extended to right here and I had my plane coming up right here, so I don't know if you can see that. If it came right to the corner and I had this, then all of a sudden they'd be on the same plane. I could take a paper and slice right through that. They'd be on the same plane. So I'm moving it to a different plane. You have to think three-dimensionally. If they're on a different plane, they can't intersect. Those lines are called skew lines. What are they called? Get ready?
Skew lines.
Skew lines. They're in different planes, so they can't intersect. And that's the principle between keeping planes from colliding in here. They're in different spaces. All right, so next is angle. Two rays with the same endpoint. This is where we get fun because we get some of our geometry tools. All right, an angle looks like this. We get two rays. They share an endpoint. Let's call it, here's ray ED, and here's ray EF. The way I name my angle is I say angle DEF. A wrong way to name my angle would be angle EDF. Why? Lucas.
Because then it would sound like it's going from E to D, then D all the way down to F.
Yeah. Someone described an idea, say, like this is a street in Paris. None of the streets in Paris, I've been there, they don't hit perpendicularly. They're like always on angle. So you got a building. They literally have like weird shaped buildings. They'll have a building like this. Well, you can't, and there's another building here and another building here. But you can't cross from D to F. You have to go from F to get to the corner, and then you have to walk over to V. You have to go in order. So E is the center or vertex. So you have to name the center or the vertex in the middle of your name. AJ?
Could we do it fed and not just D?
That's a great comment. Can the order be reversed? Yes, as long as your vertex is in the middle. Okay, vertex goes in the middle. What goes in the middle, class? Get ready?
Vertex.
Vertex, very good. So how do we measure the size of an angle? We use a cool gadget called a protractor. We put the divot or the center hole, you guys probably have a little hole, Spencer, wait. And you line it up on the bottom line and you say, oh gosh, I have two rows of numbers. Is it the smaller numbers or is it the bigger numbers? So this angle is acute, it's less than 90, so I'm going to use my smaller numbers. Thank you, Spencer. So we're at about, looks like right there. And so it's on the between 70 and 80, so it's 78 degrees. That's how I measure my angle. One other naming convention about angles is if there's a number inside it, I can say it's angle 1. I can also say angle B. What can I not do? If I have another angle created from B, maybe this is angle 2, I can't call it angle B anymore because I don't know which angle B you're talking about. In fact, I have a large angle, an angle 1, and an angle 2. So you can't call it angle B. You have to say A, B, C, or A, B, D, or C, B, D. Okay, so you have to be careful with your names. Okay, our last one, we're going to measure an angle using my built-in board protractor. And we're going to find the measures, little m means measure, B-O-A. So let's look, it's acute. So it's between 60 and 70. Halfway is 65, so it's just before 65. It's going to be 64 degrees. Let's find this one. This one's obtuse, it's bigger than 90, so we're going to use my bigger numbers. It's between 110 and 120. It's just past halfway, so it's 115 plus 1, 116 degrees. Notice the math. If I add the 2 degrees together, 6, 7, 8, 180 degrees. So if you've got 180 degrees and they're sharing a line, it's called a linear pair. What is it called? Get ready.
Linear pair.
Linear pair. It's also a straight angle. Straight angles add up to 180 degrees. So we're gonna do a few work with. Oh, we skipped my acute, right, and obtuse, and straight. Okay, with your arms, everyone, we're gonna build some angles. You get your body moving a little bit. Okay, take your arms. We're gonna make an acute angle. Acute, 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 acute. Ding. As soon as you hit 90 degrees, it has a new name. It's called a right angle. What is it called? Get ready.
Right angle.
A right angle. What are these angles called? Get ready.
Acute.
Acute, because they're a cute little angle. It's acute, not cute. Someone tried to name it cute. It's acute. Okay? Acute, 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 acute. Ding. It's a right angle. As soon as we pass 90 degrees, it has a new name. It's called obtuse. What is it called? Get ready.
Obtuse.
Obtuse. I remember that name because I think of someone who's an obtuse person. They're loud-mouthed and they're in your face and they're like obtuse. And so I think of this big loud-mouthed angle. Okay, it's got a big wide mouth. It's an obtuse. Okay, then what if I could open my arms all the way flat, which I can't. I'm going to go this way and cheat. If you have an angle that's totally straight, it's called a straight angle. What is it called? Get ready.
Straight angle.
A straight angle. It's 180 degrees. How many degrees? Get ready.
180 degrees.
180 degrees. We also call it supplementary for another lesson. Okay, you're on page 117. We're going to do all practice set problems A through J. 3 at a time on your board, please. No par today.